Okay, first thing we have to understand is why does cross multiplying work? Whoa, there we go. Why can I just say 12 equals x minus 5 and x plus 1? Why can I do that? It's been proven to work. And actually, I like that. It's been proven to work. But we're going to reprove it really quickly here. So if I want to get this 4 to the other side, I can times this side by 4. And so I cancel that out. And then we would times this side by 4. That's why I'm getting 12 right there. Here, I would times this side by x minus 5, and that cancels that out. But then over here, I'd also times this by x minus 5. And then I would just multiply through. So that's why it works. And we're just going to build on that today. So we're going to use that one fact. And then actually, if your denominators that you've been dealing with, gone. We get rid of all. We just give them a nice little wave. Say bye-bye. And we don't have to deal with it anymore. So it's kind of nice. Let's see how this works. We're going to skip this first one because it just confuses you, not because of time. We have plenty of time today. First thing you do, factor. You always factor. And I don't so much care about what's on top. I care about my denominators right now. Now, we still have restrictions, but I'm going to ignore that because we've done that a little bit. It's not new, so I want to focus on what's new right off the bat. So I'm going to factor the bottom here, and I'm going to write this as 6 times, and what's the bottom piece factor there too? Yeah, x and then x minus 4. So we can take a greatest common factor out. You always want to take that greatest common factor out if you can. Then I got a plus sign. And I have 4, I can't factor anything, so I just got x. And then I have 2, and I can't factor anything, so I just got x minus 4. What is my common denominator going to be? Any guesses? X. X is part of it. X and x minus 4. That's going to be our common denominator. So what we're going to do, and I really only do this step once, is I just take this whole problem here and I multiply it by my common denominator. So I'm going to put my common denominator there. And let's multiply. What happens if I multiply 6 by x times x minus 4? What happens? Can I cancel anything out? We can cancel everything out, right? Because this is what I'll get. And I normally don't work through all of this, but we will, so we can see it. And look at that, gone, right? So I just got 6. And that's because I'm using a common denominator to multiply to the whole thing. Then I put a plus sign. Now, let's think about this. I got 4. I'll change that. So I got 4 here, and I'm going to times it by x minus 4, and then on the bottom here I have an x. What cancels out? The x's. Okay, so we're going to deal with that in just a moment. And then I'm going to have equals, do that in green. And I have this 2 right here, and we times it by x minus 4, but on the bottom here is an x minus 4, so that cancels out, and I just got 2x. So, do I have a denominator anymore? No, I don't. I just have this big, ugly looking fraction. So, let's count, or not fraction, just big, ugly looking whatever that is. So let's take a look at it. 6. 6 times what here? Just 1, so it's just 6. Then I go plus. I go 4 times x, 4 times negative 4. So I'm looking at 4x minus 16. And then here I got 2 times x. Now we solve that. In this case, normally we either want something to equal 0, we want everything on the same side, or we want a positive x. Now, having everything on the same side is going to trump the positive x, but in this case we still get it. So I'm going to just bring this negative 2x over, and I'm also going to combine my pieces. So I got 6 minus 16, that's going to give me a negative 10. And I got 2x. So 2x minus 10 equals 0. Solve that. You don't need my help for that. Just get that answer. You can. Yeah, you can. It doesn't matter how you do it. What do you get? Positive 5. Okay, so we get 5. That's my answer. Now, we have to go back up here. Take a look at this. My restrictions. Well, I really just have to look at my common denominator out there. So, what would make x or x minus 4 0? What two numbers? X cannot be 0 and what else? 4. You like that? All right. Good. Was our solution 4? No. Was our solution 0? No. So it works. Now, question. Why are you looking at 1? Why are you looking at 1? Oh, okay. I thought you said 1 before.
I said 4.
Oh.
That was stupid. That was okay.
I heard 1, but I don't. Proves me back.
I heard 1 too. Yeah.
That's right. He looked at you like you might have been more than stupid. But. All right. Hey, we're just bringing you back to support time, right?
Oh, okay.
All right.
Let me know.
All right. Questions? Okay, next one. This is how we do it. We're going to do this one slightly different. It's the same thing, it just looks a little different. So first thing we do though, we still are going to factor that thing. So I got 1 over x minus 6. Then I'm going to go plus, and then x over x minus 2. And then I got an equals. Notice I'm giving myself a lot of space. Give yourself a lot of space as well. 4 over, what's that factor to? Yeah, and that's pretty common here. And the reason it's pretty common is because we're not necessarily testing on how well you can manipulate every single piece out there. We're looking at, can you take rational expressions that are added together and equal to something, and can you solve that? So we're not going to try to make that anything more insane than it has to be. Now this is the slightly different way of doing this. I look at my denominators here. I have an x minus 6, I have an x minus 2, and then I have those two things put together. So what's my common denominator? Yeah, what's on the right? The x minus 6 times the x minus 2. It's got all the pieces that are needed. So if I look at that, this is the other option of doing these problems, is x minus 6 is missing what? So it has a common denominator. X minus 2. So I'll just put my parentheses there. I'll go x minus 2. But then I also got to go x minus 2 up here. I look at the next piece. And x minus 2 is missing what? X minus 6. So just the piece that wasn't there. So I go x minus 6. And then I got x minus 6 right here. Top and the bottom. Right? You just take whatever was missing and multiply it to both the top and the bottom. Now, the last problem, I just said, hey, let's just take all of these pieces and times it by x minus 6, x minus 2, what my common denominator was for that problem. And so our common denominators went away. Well, folks, if you have a common denominator, guess what? It's now gone. You don't have to deal with it. And that's because if I would times the left side by x minus 6, x minus 2, I times the right side by that, and it all cancels out. And I don't need you to show all that canceling out because it's really just cross multiplying. It's just a little more fancy. So this is the other way of doing it. This is honestly my preferred way of doing it. However, you've got options, so I show you both. Let's work through it. So I get 1 times this. That's pretty easy, x minus 2. I go to the next piece. I got a plus sign. I'm just going to drag that plus sign along for the ride, and I got x times x, so x squared, x times negative 6, negative 6x, and then equals 4. Let's organize this jigsaw and move it around. So I'm going to take that 4, slide it to the left. So I'm going to minus 4 from both sides, but I'm also going to write this in standard form. So when I write this in standard form, I'm going to have my x squared come first. This makes it easier for when you have to factor, or if you have to do quadratic formula. I'm going to combine my x's here. It looks like I got a positive x and a negative 6x. So that means I have how many x's? Perfect. So negative 5x. And if you want, you can cross those pieces off so you don't get confused. Now I got a negative 2 and a negative 4, giving me negative 6. What's that factor to? What's your solutions?
-1. What is that for this time?
I deserve that attitude. That was fine. All right. Yes, so we get x equals 6 and x equals negative 1. And now we go look at our restrictions. What do we get for our restrictions? X cannot be and. So that means we cross that off. Question.
This is jump right in.
Jump right into the next one. Anything at all. Before we move on. Okay, this one throws people for a loop because of the 1. What am I dividing 1 by? 1. So we can rewrite that as a fraction and make it just 1 over 1. Now, the other thing I'll say is let's also factor the piece on the bottom. So x squared minus 2x is going to be what? X times x minus 2. And you also want to do this because this helps me find my restrictions. If I want to find my restriction, the first thing I'm going to do to find my restriction is factor that. So like you have to do it either way. Now I got a minus 1 over 1. And then I got 1 over, and same thing, so it's just x and x minus 2. What's my common denominator? Yep, so I don't have to do anything for the first piece. Don't have to do anything for the last piece. So it's really just this middle piece. I'm going to go x times x minus 2. Now, this is where you get to be a little bit lazy if you think for just a little bit. In the bottom, do I ever really try to put this in standard form, the denominator? No. So I'm going to leave that. But in the top, I do try to put this in standard form, right? So what's standard form of x times x minus 2? X squared minus 2x. I don't have to do any work. It's already given to me. So I'm just going to put that there, x squared minus 2x. Now we got the same denominator, right? Yep. Gone. So So let's write out what we have. We have x plus 5 minus 1 times x squared minus 2x. This is the first subtraction that we've dealt with, which equals 1. All that does is flip our signs in here, which is why I'm making us do this step, but I get x plus 5 minus x squared plus 2x equals 1. I want you to go ahead and solve that now. I'm not going to help from there. You can talk to each other. What restrictions do we have? X cannot be 0 and 2. Questions? Now, this lesson is pretty short, but it's also a pretty difficult lesson. It's honestly one of the hardest things that you do this year. Okay, like all of that. This is. Okay? It just takes practice. So like, we give you a lot of practice because we could do these till we're blue in the face, but until you start looking at the problems and like start realizing, oh my gosh, I don't know what's going on there. Well, then you got to ask and you got to figure that out. And we'll talk about it. But again, you're in class, you're with your peers, work together. So please utilize this time to do that.